Welcome to collecting data. Some of the key ideas in this section is looking at how we collect our data, the method involved, and of particular importance is we're striving for the gold standard, which is a simple random sample. Statistical methods, right? The types of things we can run are driven by the type of data that we have. If we have numerical data, we can do certain types of analyses. If we only have qualitative data, then we're limited to only certain types of analyses. So the type of data we have really drives the type of analyses we can run. So oftentimes when we're designing our research projects, we have to think about what kind of analyses we want to run and then make sure that we're collecting the appropriate kind of data. Now typically we only have two types of studies, observational studies and experiments. An observational study is where we're basically just watching things happen and we have no control over modifying the path that things take. Whereas an experiment is where we have some sort of treatment effect that we give to one set of objects, subjects, normally human beings, and see if it causes a different trajectory, i.e. give one set of patients a placebo and give the other set of patients an actual drug and see if one has an effect on how quickly they recover from something. Here's an example of the Pew Research Center surveying a bunch of people and finding out how many of them go online wirelessly, and that's just an observational study because all we're doing is collecting data about a bunch of objects and we're not actually manipulating them or affecting them in any way. Whereas this is an example of an actual experiment because children were given a placebo and other children were given the Salk vaccine and seeing if there was a difference in, I believe this was polio. Convenient sampling is a type of sampling where all you're doing is collecting data from things that are convenient to you. So maybe you're just collecting sample from people in your class, people in your school, people in your building, people in your neighborhood, whatever it happens to be. Systematic sampling is where you have a group of data, objects, people, numbers, whatever, and you decide to pick every 7th number or every 100th number or every, in this case, 3rd number. A random sample is just a sampling technique in which each item, or in this case members, has the same probability of being chosen. If you took your entire group of data and numbered them, ordered them somehow, right? So you want to sample people's salary, and you've got a list of 5 million people and all their salaries, and you list them alphabetically by their last name. Then you decide to choose every 10th person, and that's going to be your sample. Well, that is technically a random sample because the ordering of them is really random. I know you're thinking, no, it's not random. It was alphabetical by their last name. Yes, that's true. But the amount of money that they each earn, the numbers now are correlated to, are matched to those people. That really is a random list because it was just ordered by their last name. You could have just as easily ordered it by their social security number or, I don't know, where they live. So the ordering was still random, and then the idea that you chose every 10th was also random. You could have chosen every 11th or every 100th. So if you choose every 10th, each person still had the same random chance of being that 10th person, right? So there was still a 1 out of 10 chance for each thing to be chosen. Simple random sample is different. It has to be random, so each person still has that 1 out of 10 chance of being chosen, but each sample that you choose, so let's say you're going to choose 100 people, each sample of size 100 has to have that same chance of being chosen. And in the previous example, that's not true, because if you think of one sample, one possible sample being the first 100 people, then the probability of the first 100 people being chosen is impossible, right? Because you're choosing every 10th person, and so you can't choose any two things that are next to each other. Stratified sampling is our next type of sampling technique where you take your items and you group them. In this case, they're only grouped by gender, but you could group by multiple ways. It doesn't have to be just two. So you could think of grouping people by political affiliation, Republican, Democrat, Independent, right? There's 3. And then you take a random sample of each of those 3 groups. Cluster sampling is similar yet quite different. You're still taking all of your items and putting them in groups. This time we're calling them clusters. But then instead of randomly sampling from each of the clusters, you choose a random selection of clusters and then take all of the items from each cluster. So you could think of this as being maybe voting districts. So you take all the voting districts in the state of Washington, you randomly choose 3 of those voting districts, and then you sample every person in each of those 3 voting districts. That would be a version of cluster sampling. Multi-stage sampling is just simply using more than one of the techniques together, right? So you sample one way and then you sample another way. Here's a summary of those basic sampling techniques that we've seen: the convenience, systematic, etc., where the SRS is the gold standard we're always striving for. Now, beyond the basics, most of you can probably stop the video at this point. This is just for some of the more advanced statistical collecting techniques. Cross-sectional study, right? Data are observed or collected at one point in a time. So an example of that would be looking at the association between obesity and television watching. So you could maybe take a sample of people from the population that are interested and can be polled and asked about their height-weight ratio and the number of hours they watch. And so it's basically giving you a snapshot picture of people who watch TV and whether or not they're obese, right? So data is being collected and measured at one point in time. A retrospective study is where you go back through records and see if there's a relationship between things. So maybe you think that people with lower SAT scores are more likely to be involved in car accidents. Then you go back through the records and look at everybody who's been involved in car accidents in the last 25 years and see if there's a relationship between that and their SAT scores. A prospective or longitudinal study is extremely powerful, very time consuming, very expensive, and therefore very rare. Most people don't take the time and energy to do it, but it is very powerful. You can collect some great data. It's where you follow a cohort or a group of individuals over a long period of time. And there are a lot of these in social sciences and medicine. They're looking at people over 25 years to see if, for instance, cell phone usage results in higher cases of cancers, those types of things. Some of the designs of experiments: randomization, you want to make sure that your subjects are randomly assigned to each group. Replication is making sure that you're doing it on more than one subject, right? So like the Salk vaccine, you had a very large sample size. So you want to make sure that those sample sizes are large enough so that you can actually see if there are effects coming from the vaccine or not. Blinding is where the subject doesn't know whether they're getting the placebo or the drug, and then double blinding is where both the subjects don't know and the experimenters who are conducting it don't know. A confounding variable is something that I talked about before, the idea of every time ice cream sales go up, that murder rates go up. Well, the confounding variable there, the thing that's acting on both of them, was weather. Trying to control effects of variables: if you have a completely randomized experimental design where you're assigning subjects to these different treatment groups through this random selection process, that helps to control for various effects. And if you do a randomized block design where you block subjects based on how they're similar, so maybe you're blocking subjects by smoking levels, low, medium, and high, and then you're running an experiment on those 3 blocks, it helps you to see if smoking has an effect. Matched pairs design is where you basically just have 2 groups that are matched up on some sort of similar characteristics. Maybe you're working with twins and you put half of each twin pair in one group and half in the other. And then a rigorously controlled design is exactly what it sounds like. You're just trying to make sure that subjects are getting the different treatments. In summary, there's 3 important considerations when you're designing your experiment. You want to make sure that you're using randomization, so each subject is randomly assigned to group. You're using replication, which just means you're having a large enough samples so that you can actually see effects of treatments, and that you try to control the best you can for the effects of other variables by using such techniques as blinding and things like that. Even with all that said, there are still errors that can happen. You can have a sampling error where the difference between a sample result and the true population result, and that's just from pure chance of having a weird sample. For instance, you want to know the average height of the average height of an adult American male, and you just happen to sample a bunch of NBA players. Then you're going to get a result that is not truly indicative of the population. Non-sampling errors are basically human errors, where your sample was good, but when you were recording the data, you had a problem. Either your measurements were faulty, or you just entered the data improperly, and things like that. And that's everything.